Okay, so last time I kind of left off with this composition. So there's always two parts to a composition, or there's always multi-steps to composition. First, you have to evaluate the inside function at the point, and then whatever you output, that's what you plug into the outside function. So looking at this, I'm plugging in -1 to h. So if I look at h at -1 is going to be evaluated at 2 times -1 plus 3, which gives me 1. So this h at -1 is what I plug into f. So what is f at 1? Well, that's going to be 1 cubed minus 4 times 1, which gives me -3. So you kind of see how I did the inside function first, evaluated that. And then the outside function, I evaluate the outside function at the point that I got out of my inside function. You guys remember that from so long ago? The weekend, right? So the composition here is evaluating the inside function at 5. So f's our inside function. So I plug in f at 5. F at 5 would be 5 cubed minus 4 times 5. So that's 125 minus 20. Right? The 5 cubed there is 5 times 5 times 5. So that gives me 105. Then I evaluate the outside function at 105. So g of 105 would be the square root of 2 times 105, which is the square root of 210. And that's the answer. Square root of 210 there. So again, I take the outside function evaluated at 5. I get out 105 and I plug that in. Sorry, the inside function evaluated at 5. What I get out of the inside function, I plug that into my outside function, and that's my final answer. So up until this point, we've only done a value, plug in a point, get out a point. So now, where the composition really becomes powerful is when we plug in functions. So I'm going to take an outside function and an inside function. I'm going to take the inside function and plug it in to the outside function everywhere there's the x. Right? So one thing, anytime we talk about functions, we have to talk about the domain. What can I plug into this function? And in composition, you have to look at two things. You have to make sure the domain exists in the inside function and also the outside function, and you have to look where they overlap. When we're adding, subtracting, multiplying, we don't have to worry. The domain, we have the domain of f plus the domain of g is going to be where they overlap, right? So I only have to find the domain of f and the domain of g, so adding them is going to be the domain of f plus the domain of g. Here, I have to be a little careful because what I'm doing is I'm taking this g of x function and I'm plugging it into my f of x function. So my domain, anything that I can plug into g of x, right? So do I have any issues in g of x? Can I plug in, do I have any problems? -4, right? So I can plug anything but -4, and I don't have an issue. And that's going to output something. So f of x is 2 times g of x, which is 1 over x plus 4, minus 6. So this composition looks like 2 over x plus 4 minus 6. And the domain is going to be minus infinity to -4 union -4 to infinity. Which if you look at the function, that makes sense. I can plug any number into this function except for -4. This is what's known as the composition of f of g. But you can go the other way, g of f of x. So this time, if I have g of f of x, I'm going to take my f of x function and plug it into g. Right? So 1 over f of x plus 4 is really what I'm going to end up with. And I kind of skipped a step on this one. It's really 2 times g of x minus 6. You guys see, this is just a placeholder for the variable. So I take the outside function, and everywhere I have a variable, I input the function. So I did that here, 2 times the g of x function minus 6. Here, I'm looking at the outside function as g. So in my g function, everywhere I have a variable, I plug in f of x. You guys see that? So do I have any problems plugging in any number into f of x? I can plug it in f of x just fine, right? The problem happens when f of x equals minus 4. So you see in this setup, my denominator can't equal 0. So you can actually go through and simplify the setup. So if I take 1 over 2x minus 6 plus 4, again, this is my f of x, this is my f of x, and this is my f of x. It's just taking the shape or the form of the g function. So if I simplify this, I end up with 1 over 2x minus 2. And my domain here is my denominator can't equal 0, right? So in the domain, (2x minus 2) cannot equal 0. So 2x cannot equal 2. So x cannot equal 1. So the domain would be minus infinity to 1, union 1 to infinity. So you kind of have to look at 2 parts. Do I have any problem plugging in f of x? Right? Do I have any domain restriction on f of x? No, because it's a polynomial. Polynomials are continuous everywhere. So then you say, okay, if I plug that into my g of x function, is that going to cause me any problems? And then you have to look at where the problem happens. Looking at f of x and g of x, it might be hard to see that the composition of g of f of x is going to have issues at 1. And you can see, if I plug in f at 1, what is f at 1? 2 minus 6, which is minus 4, right? So if I take that minus 4 and plug it in g of x, I have a problem. But any other number is going to work out there. Does anyone have any questions on this? You see the outside function and the inside function and how that works? Because order is very important. Order matters. Let's look at the next example. We have to be a little careful because both these functions have restrictive domains. So if I'm looking for m of p of x, writing it should be pretty straightforward. If I take the m of x form and everywhere I have an x value, I'm plugging in p of x. So I have 1 over p of x minus 5, and then writing that as 1 over the square root of x minus 2 minus 5. See what I did there? I took this outside function, the form of the outside function, and everywhere I have a variable, I plug in my function p of x. So with domain, there's a 2-step process. The first thing is, do I have any problems with p of x? Do I have any issues plugging in numbers to p of x? We'll get there. Okay, so x minus 2 has to be greater than or equal to 0, right? Because the square root function tells us it has to be 0 or positive. It has to be greater than or equal to 0. So x has to be greater than or equal to 2. So that's one restriction on my domain. If I plug in a number that is less than 2, I get a negative number in p of x, and I can't even get anything out of it, right? That's my first step. What can I plug in to my interior function? So that's limited. Then the second step is, do I have any problems with my composition?
If whatever is in the square root equals 5.
Exactly.
5 is 0.
Exactly. So I can plug any number greater than or equal to 2 and plug that into p of x. I get something out of it. But if I get a 5, I have a problem because I can't evaluate my composition that way. So here, p of x minus 5 cannot equal 0. Right? So if I go ahead and write what that means, the square root of x minus 2 cannot equal 5. Right? If I add 5 to both sides, I end up with this expression. Do you guys have an idea how to solve this for x? How can I get rid of a square root? Square both sides, right? So if I square this side and I square this side, that tells me x minus 2 cannot equal 25. So add 2 to both sides. X cannot equal 27, right? So the composition function is written like this, but my domain has to satisfy both the condition that it has to be greater than or equal to 2, but it can't be 27. So if I drew a number line here, I would be 2 to infinity, but I would take out 27. Right? So I would write bracket 2 to 27, open parenthesis, union 27 to infinity, close parenthesis. Any number in that region, any number in that domain is going to have an output to the composition. Question?
I always get confused on brackets. Why specifically the bracket?
The bracket means it can equal 2. The parenthesis means it's going to be every number up into that number, but not that number.
Okay.
So you're going to use a parenthesis when there's an open circle, and you're going to use a bracket when there's a closed circle. Or greater than or equal to here. Since this is in the numerator, it can equal 0. If it was in the denominator, it couldn't equal 0. So it would be an open circle. But that's a good question. And hopefully we'll have some time to pull some Alex-like questions, and we can see how they'll want you to enter it. So do you guys see what's going on there with composition? You're just plugging in the inside function to the outside function. But you have to be a little bit careful with the domain, because sometimes some things are lost when you write the composition, or some things are forgot about. It could be possible you ask to decompose a function. So this is a composition function. You need to come up with the outside function and the inside function. So really this is saying f of g of x. What would the inside function be, and what would the outside function be? Any ideas here? So if I had g of x to be 2x squared minus 5, what would f of x be? This absolute value of x. So if I have f of g of x, I take the inside function here, plug it in the outside function everywhere there's an x, and that would give me the absolute value of 2x squared minus 5.
Okay, so
how did you get absolute value? So the absolute value is a function, right? So it's the absolute value is kind of the outside function. So another example that might come up would be x plus 2 cubed. What would be, if this is f of g of x, what would be a g of x? And what would be an f of x? The inside function is what?
G of x.
G of x, which is x plus 2, and the outside function is something cubed, right?
Okay.
You see that? So if we go on, let's say f of g of x, if I had something very similar, maybe the square root of x plus 2. This is a little, let's make it x plus 2 minus 5. So this would be, g of x would be what? X plus 2, and what would be f of x?
X minus square root of x.
Very good, the square root of x minus 5. So you can see how I can kind of work backwards on some of these. If I have the outside function, that's just the general form. The inside function is maybe possibly what's going to be done to that. So x plus 2 is being plugged in to this function here, and it looks like this. Here, this x plus 2 is being plugged into this function, and it looks like this. It's not very typical where you decompose functions. Typically, you'll go the other way. I think this graph is a really good type of problem to see, do you really understand what's going on here? Because there's no algebra, it's interpretation. Do you know what f plus g at 1 means? Right? So what this is saying is f at 1 plus g at 1. So from the graph, f of x is kind of the blue line, and I know on your guys' paper there's not really any coloring, so you might like dash it and say this is f of x is the dash line. So what would be f plus g at 1? Well, you would have to say, what is f at 1? So f at 1 is 4. And what is g at 1? Minus 3, so that would be 1. You guys see that? Saying f plus g at 1 is you take the f function at 1 and you add that to the g function at 1. So f at 1 would be 4, and g at 1 would be minus 3, and 4 plus minus 3 is 1. What about the multiplication? This is f at 0 times g at 0. What would be that answer? Would it be 0? This is the function evaluated at 0. What is f at 0? When you plug 0 into f, what do you get out? 4. And when you plug 0 into g, what do you get out? What? Negative 4. So what's 4 times minus 4? Yeah, this is multiplication. Yeah, so it wouldn't be the addition, it's multiplication, right? You have to be careful with subtraction too. So you can kind of see here, I wrote, 4 plus a minus 3. If this was f minus g at 1, it would be 4 minus a minus 3, which would be 7. So let's look at, this is going to be g at minus 3 minus f at minus 3. What is g at minus 3? Minus 1, right? So this is minus 1. What is f at minus 3? Is it 1? It's open. So it's no point, right? So it doesn't exist. Sorry, guys. I don't know why it does that. Pull that over there. So the open circle means if I plug in minus 3 and it's an open circle, it means it doesn't exist. There's no point. So it's not in the domain. If I was to write the domain of f of x, it would be open -3 to 5 closed, right? So I can't plug in -3 into the f function because it's not in the domain. So we would put does not exist, and therefore your answer would be does not exist because it's not in the domain. If this was a function and you plugged it into your calculator would say domain error. You can't evaluate something that's not in the domain. That's like if I had the function 1 over x, this is f of x, and I ask you what is f of 0? Does not exist. It's the same thing with the graph, that open circle. Question? D&E is fine. No answer, doesn't exist, blank, all that would be fine. So really, I think the power here is the composition. If you can do the composition on a graph, you really understand what's going on with composition. So f of g of 3. What that means is I take g of 3, right? What is g of 3?
2.
G of 3.
-1.
F of 3 would be 2, but g is the bottom function, the pink one. On your paper, you can't really see the color, so right, g of 3 is -1. Does that make sense? Yeah. Just yeah, got them. So g of 3 is -1, so that means I evaluate f at -1. What is f at -1? What is it? Yeah, it's 3. I understand your paper. It's kind of hard to see. So that would be 3. So f at -1. So what I do here is I plug 3 into the g function and I get out -1. Then I plug -1 into my f function and I get out 3. That's how composition works. You see it's different than addition and subtraction, multiplication, division. The composition is you take the inside function, you plug that in, you get something out, you plug what you get out into the outside function. What about E? G of f of 4. So I need to find f of 4. What is f of 4? 0. So then I'm saying I'm plugging in 0 into my outside function, g. So what is g of 0? -4. And that would be the answer there. So I take my 4, I plug it in f, I get 0. So then I take 0 and plug it in g, and I get -4. And the last one, I have f of g of 1. What would be the answer there? Very good. It'd be f of -3, which we already knows does not exist. Right? Because I plug 1 into g, I get out -3. It means I plug -3 into f, and there's no answer there, so it doesn't exist. So if we go into Alex, this is where we left off on Alex. Suppose that U and W are defined as the following. You want to find the composition of W with U at 3 and then U with W at 3. So we work those out. And we'll snip it. So W composed with U at 3. So I'm going to plug U at 3. So that gives me 3 squared plus 6. Gives me 15. Then I plug this 15 into the W function. W at 15 would be the square root of 15 plus 1, square root of 16, which is 4. Did you guys see that? What would you get composing U and W at the point 3?
No, the final answer would be
Just throwing out an answer. If doing this part, what'd you get?
10. Well,
10? Did anyone else get 10?
yep.
10 is the correct answer, right? Because what I do is I add, the inside function is W, so what is W at 3? The square root of 3 plus 1, which is 4. Then I take my 4 and plug it in U. So what is U at 4? And that's, sorry, 2. Square root of 4, which is 2. Which would be 2 squared plus 6, which is 4 plus 6, which is 10. I say W at 3. I get out 2. I plug the 2 into the outside function, and I get out 10. We get 4 and 10. Oh, I don't think I filled out the other one, so don't worry about it. In the past, I put one of these on the exam because I think it really shows you understand the composition and the domain and range. But honestly, there's not a lot of application here. There's not a lot of application because this is not a function. But if you can do this, you understand domain and range. Okay? So this is f. This is saying this is the f function and this is the g function. Find the domain and range of the composition g of f of x. Right? So domain is going to be the numbers I can plug into f of x that gives me an output at g of x. Right? So if I plug in 0, sorry, we're composing g with f. So be careful because these are randomly generated. Yours might be f with g or it might be g with f. So I'm looking at this function. This is what I start with. I take 3, it gets mapped to 3. I jump over here and 3 gets mapped to 3. That works. That's fine, right? So 3 is in the domain of my function. The range is everything that it outputs to. So 3 is also in the range. Do you guys see that? 3 goes to 3, then 3 goes to 3. So this is my first function, my inside. This is my outside. So 3 gets mapped to 3. Then I take what it gets mapped to over here, and it gets mapped to 3. So 3 is in the domain and the range. The next thing I try is 8. 8 goes to 3, and 3 goes to 3. So that adds 1 to the domain, but it doesn't add anything to my range because I already got 3 in there. 9 goes to 9. 9 goes to 8. So this goes to 9. This goes to 8. So that's all. That's all my answers. I only have 3, 8, and 9 to start with. So 3, 8, and 9 are the only possibilities to be in my domain. 3 goes to 3. 3 goes to 3. That worked. 8 goes to 3. Oh, is there an 8 over here? There is not an 8 over here, is there? So 8 is not in the domain anymore. Right? I can take 8 and it goes to 3. Oh, no, I'm right. Sorry. The original question. 8 goes to 3, then 3 goes to 3. So it is still in the domain. 9 goes to 9. So 9 goes to 9, then 9 goes to 8. So that would be the domain and range. Let's see if we can pull up another example of this where it might take something out. So out of my possible domain, I have 3, 8, and 9. Out of my possible range, I have 0, 3, and 8. 0 is not in my range because nothing's mapped to 0 from my domain. So do you guys see that on this problem? Let's pull up another one. That's somewhat similar. On Blackboard, I have posted a review that we'll do tomorrow, but on the review, there's one I want to go over. So I'll give you this handout tomorrow that just has sample type problems. It's already posted on Blackboard if you want to look at it before then. This is the one I want to look at. So here we're looking at the composition of f and g. So I'm looking at this function composed with this function. So this is my inside function. This is my inside function in this case, and this is my outside function. Right? You see how you have to be a little careful because these are randomly generated. So if it's f composed with g, that's different than g composed with f. You start with the inside function. So here we're going to start with this side. This is my possible domain, 3, 4, 5, 7, 8, 9. I need to make sure everything is mapped to something in the range. If not, I have to take it out of the domain. So 3 goes to 9. Is there a 9 over here that goes to 8? So 3 and 8 would be a pair. So domain, range, 3 and 8. I start with 3 is in the domain, and it maps to 8. Then I try 4. 4 goes to 7. 7 goes to 8. So 4 basically goes to 8 in the composition. So 4 is in the domain, 8's in the range. 5 goes to 6, 6 goes to 8. So 5's in the domain. 7 goes to 5, but there's no 5 over here, is there? I know it's not necessarily 100% clear, but 7 goes to 5. There's no 5 to map over here. So that means 7 is not in my domain of my composition, because if I plug in 7, I get out 5, but there's no 5 to plug into my outside function to get anything out. So 7 is not in the domain. 8 goes to 1. There's no 1. 9 goes to 1. So there's no 1 over here. So 3, 4, and 5. 3, 4, and 5 are in my domain. 3, 4, and 5 go to 6, 7, 8. 6, 7, and 8 all go to 8. So 8 is the only thing in my range. So my domain here is 3, 4, and 5, and my range is 8. You guys see that? You have to be careful to say, okay, if I plug it in my inside function, what do I output? Is that output in the domain of my outside function? If it is, then it's in the domain of the composition. If it's not, then you have to take that out of the domain of the composition. You see how it's a little more complicated than addition, subtraction, and division? And honestly, after this section, you'll never see a picture like this again, but it really goes to show you, do you understand the composition, that I plug something in the inside function, I get something out. I plug what I get out to the outside function, and I get something else, and I get my answer. Domain and range is what you plug into the inside function. Range is what you get out of the composition. So in this case, you're just going to enter it as a set. So you just put the set notation, and then you put the numbers in with commas. There's no interval notation there. And then this example here is a composition. So you're composing G with H. So G composed with H, and then you're going to look at the domain. So here we have to be careful. If H is the inside function, do I have any problems with H by itself? I can plug anything into H, no problems. But when I plug it into G of X, I know H of X therefore cannot equal 1. Because when I plug something into H of X where it equals 1, I have an issue with the composition. Okay. So here the composition is not going to be that bad. It's going to be 4x plus 9 plus 4 divided by 4x plus 9 minus 1. And then you can simplify that. Do you guys see how this is f of x, and this is f of x, and it fits this form? And then the domain, you have to worry about the denominator equaling 0. There's no problem with your inside function. So it wants interval notation. Might be a fraction. That's okay. Fractions aren't going to hurt us. So it's going to look something like this, where you have minus infinity to some number, union some number to positive infinity. And it will say simplify, so you should have to simplify the numerator, so, and the denominator here. So this would be plus 13. This would be plus 8. Was it plus 8?
So that
So
domain would be like 1, -9.
the domain would be, there's only a problem at when 4x plus 8 equals 0.
Oh, and -2.
So it would be -2.
So it would be minus 2 here. Go ahead.
I was saying you don't do you don't set the G of X to 0, you set the G times H to X to 0.
Yeah, so you set where you have problems. So you look at the inside function, G of X. G of X, does it have any problems? No, it's a polynomial, it's continuous everywhere. So then if I was to plug it in this function, would I have any problems? If this was H of X minus 1, I would have a problem with H of X equals 1, right? So where does 4x plus 9 equal 1 at? So I'm looking for when does 4x plus 9 equal 1. So subtract 9 from both sides, and that would be 4x equals minus 8, which would be x equals minus 2. And that's kind of what we did, except we can see it already as we compose it. The denominator 4x plus 8 can't equal 0. Does that make sense? So yeah, really we're looking at where we have problems. We don't have any problems in our inner function. We have a problem with our outer function when the denominator equals 0. So that would end up being that. Looking at, I didn't answer a lot of these, but I answered the last one, so you should see that it was correct answer there. assignments. Assignments are due Thursday at 11:59 p.m. So Alex is gonna take a snapshot of where you're at in your pie and on your homework. So your homework's unlimited. You can go in there unlimited times and try it, and it's gonna keep the highest score. So ideally, getting 100% on those would be great. And then on the pie, you should be able to see how far you are in your pie by telling you how many objectives you've reached. So I've only done 2 out of the 42, so I need to be working in there some. So it's a balance between working in the pie and working in the homework. Like I said earlier, we're going to review Wednesday. So today's the last day of lecture for exam 1 material, which is over chapter 2. I'm going to review on Wednesday, and I'm going to give you that packet that I have here that starts with the objectives for each section. So ideally, you should know 2.3 covers this, 2.6, 2.7, and 2.8 cover these types of things. So you should be able to know how to compose and decompose a function, how to perform operations on a function, test for symmetry, things like that. And then I've included sample problems. So some of these are just screenshots of Alex, and some of them might be screenshots of your book. But anything like this is free game for the test. And you should be able to print this off, or I'll actually bring you copies to class. I also have a summary page of what was covered in 2.3, 2.5, 2.6, and 2.7. And then the test will be on Friday.
So should we try to like see that we can work those, and if we can't?
Ideally, exactly, yeah. So we only have 50 minutes in here on Wednesday, right? So I can't really lecture over 4 sections because that's been 3 weeks of material. So ideally, you would go through, write them out, say, oh, I know exactly what this is asking. And then I'll post the answer key on Wednesday. Wednesday after class, I'll post that. Or Wednesday during class, I might have it for you posted. So ideally, you would say, oh, I got this right. I know what I'm doing. Or I have no clue how to do this problem. Can you please help me start it? Yeah, because it's kind of like a pre-test, if you think of it that way. Kind of give yourself, you sit down before Wednesday and go through that. That's going to give you better prepared on Wednesday to say, listen, I have no clue what this is saying. Being able to get that answered before the test on Friday. All right, I will see you guys Wednesday.